Assalamualaikum and hi. In this video, we are from Group 1 Class B will be presenting about our work project entitled Controlling an Inverted Pendulum. The structure is inverted 100-degree angle from its equilibrium position. The main characteristics of the system are highly unstable and highly nonlinear system. Feedback control system is commonly used in inverted pendulum application in order to stabilize the pendulum position. It is responsible for monitoring the pendulum's angle and adjusting the position of the pivot point sideways when the pendulum starts to fall or unbalance. In this project, we will design controllers denoted as K as the adjustable parameter to encounter the disturbance input. In task 1, since we are attempting to control the pendulum's position, we should return to the vertical after the initial disturbance. As a result, it will be resulting the new transfer function for the closed loop system from an input of force to an output of pendulum angle. We assume that the K value at the first is 200. As a result, we get the Bode diagram as shown. Also, from the Bode diagram, we can estimate the value of them for the damping ratio and the frequency using the formula.
For task 2, this is the coding that we use. From the coding, we can gain the root locus, and from the root locus, we can gain the damping ratio, overshoot, and frequency. But we cannot gain the sampling time. Next, for task 3, for the block diagram, I choose the value of K is 50 and 100. But as we can see, the graph is as the same, even though the value of K is different.
Screen, this is the bandwidth frequency for the axis from 50 to 100 for the x-axis, and for the y-axis -2 to 2. From the M-script coding beside, this is what the result that we get. Next, for the second axis, which is from 90 to 100 for the x-axis, and for the y-axis is -1 to 1. And from the coding equation beside, this is what the result that we get. The Bode block diagram with the K equal to 50. The K that we use is 50 and the time set is 0.04 second. The time rest that we get is 0.0439 second and the overshoot is 0%. This closed loop system is stable.
For the conclusion, we can conclude that all the result and graph we can get from the MATLAB software automatically when we input the correct coding in the MATLAB software, such as Bode plot, step response graph, and also the root locus graph.